examples. We're only going to do a few today, so don't think I'm going to try to pack all this into a half a class period. This is for the next couple days. But my general guidelines, when we are doing word problems, the first thing I'm going to ask is that you identify your variable. All right, it's fine if there's a simple problem and I'm asking a single question. Everybody knows what X stands for. But the problem is we're going to have problems where there's a couple different unknowns, and I may not know what your X represents. So that is the first thing. That's an easy point. If you get nothing else right in your problem, you get a point for telling me what X stands for, or whatever your favorite letter is if you don't like X. So always tell me what your variable is. Second, later on in the year, we'll refresh. You've done systems of equations, but right now we're not. So I don't want X, Y, and Z in a problem. Everything needs to be in terms of the same variable. So X and X plus 1, or whatever the case might be. Don't have multiple variables, everything in terms of 1. Third step is set up a model. That's really just your equation. So we have to figure out what it's asking us and write an equation. And then we can solve that equation. Make sure your answer is reasonable at the end. You know, if I'm asking you how long is the side of a triangle and you get -6, is that a reasonable answer? No, you've made a mistake somewhere. So go back and figure out where you went wrong. And the last thing, answer in a sentence. Every problem, you have to tell me your variable, you have to answer in a sentence. Even if everything else is wrong, you get 2 points if you do those 2 things. Even if everything else is perfect, if you don't tell me your variable and you don't write a sentence, you lose 2 points. Okay, so those are easy points, but I do expect that on every one of these. So, I kind of have them broken down into different topics that we're going to look at. There's really 3 main types that I'm going to hit out of the section. The first ones, I called it geometry. So these are ones where maybe we can draw a picture. Sometimes a picture may not be required, but where pictures might help, that's like our geometry type problems. We're only going to look at those today. And we'll see if I get through all my examples or not. So here's the first mistake I see. When I give people a word problem, they look at it and they go, okay, if the length of each side of a square is increased by 3 centimeters, the perimeter of the new square is 40 centimeters more than twice the length of each side of the original. I don't understand. And do you guys have any clue what I just said? No. You cannot just read the entire word problem and magically know where to begin. Let's back up and take a little at a time. If the length of each side of a square, pause. What do I know right now? We have a square. Draw a square. Okay, here's my square. So I come back up here. If the length of each side of the square is increased by 3 centimeters, what's happening to my square? It's getting bigger. Okay, so this is my old square. I had started with a small one and then I made it bigger. So here's my new square. All right. Let's see. Did I tell you how big the old square was? So what could I call the length of the side? X. And we know it's a square, so they're all the same, right? If you need to write it on all, you can. If you just write it on one, that's fine. But how did I get the new square? Yes, increased by 3, so that's adding 3. So this is x plus 3. I don't want to say it's y. We only want a single variable. So the new square, every side is x plus 3. All right, any questions about how I've gotten that part? So right now, I've identified my variable. I didn't say x is the length of the square, but I drew a picture and I labeled it, so that counts. Second thing, I put everything in terms of the same variable. I didn't say x and y, it's all in terms of one variable. So I'm on step 3. I'm ready to write an equation. So let's go back and read. The perimeter, how do you get perimeter? Add all the sides of the new square. So I want to add all the sides of the new square. So I could write x plus 3 plus x plus 3 plus x plus 3 plus x plus 3, or what could I do?
4x plus 3.
4
times x plus 3.
Yes. But if you prefer to write them all out, you are welcome to. So that's my perimeter of the new square. Is, that's magical word. What does is always mean? Equals 40 centimeters more than, what's more than telling me? addition. So we have 40 plus twice, what does twice mean? 2 times the length of each side of the original square. 2x. The original square had a side length of x, so 2 times that would be 2x. Now, do you guys all know how to go from here? Take a second and solve this equation for me. So we get 4x plus 12. Okay, at this point, it is totally up to you how much work you show me. If you like to write what you're doing, that's great. If you don't, I'm not going to count off as long as you do it correctly, okay? So you can subtract over your 2x. Did you guys subtract the 12 at the same time? Would that confuse anybody if I did it? So we get 2x equals 28, divide by 2, so x is 14. If I'm ever skipping steps that you need to see, don't be afraid to tell me to show more work, okay? So did everybody get 14? Am I done? No. What is the very last step? Step 5. Answer in a sentence. So let's look back. We have to answer the question. I want the dimensions of the original square. What do I mean by dimensions?
How long each side is.
Good. So the original square has sides 14, what were my units? Centimeters long. Okay, but if I had asked you for the sides in the new square, how long are the sides in the new square? They are 3 more, so it would have been 17. So you have to make sure you go back to the question and that you're answering the correct question. All right. What questions do you have for me there? That one's okay? Let's look at the next one and see if we can figure it out. So a rental car company charges $20 per day and 30 cents per mile for renting a car. Is there any picture I can draw here that would really make sense? No. Okay. Pictures are optional. If they help us, great. If not, we don't need them. Janice rents a car for 3 days and her bill comes to $72. How many miles did she drive? Now, could you figure this out without writing an equation? Probably. And in general, if you can solve a problem using a different strategy than what I'm teaching, I'm fine as long as you can explain that to me. But let's try to use an equation to solve this. What is my unknown? What am I trying to find? How many miles? So that's going to be my variable. You can call it x, m, whatever you like. Since I don't have a picture, I'm just going to say x is the number of miles. So I've just defined my variable. 1 point. Second thing, is there anything else I don't know? No. So I don't even need to worry about step 2. There's no other unknowns. We're ready to just write an equation. So we know we're charged $20 per day, 30 cents per mile. We rent the car for 3 days and the bill was $72. So I have to come up with an equation for that. The $20 per day, how many times do I have to pay that $20? 3 times. So 20 times 3. If you went ahead and wrote 60, that's fine. And so in addition to that, so plus 30 cents per mile. What would I do there? 30x. Is there a problem right now? Yes. That is 30 cents, so I need to make it 0.30x. Equals, how much money did we owe? $72. So 60 plus 0.3x equals 72. Subtract over the 60. Divide by 0.3. You're welcome to come grab a calculator anytime you need to. Just walk over and grab one. Get one for your friends if you want. get 40?
Yes.
And so what do we need to do to finish it?
Write sentence.
Write a sentence. So Janice drove 40 miles. Are those problems okay? What I want you to do now, I'm going to give you a couple minutes. I want you to read the next problem and see if you can just draw the picture. Okay, we'll check the picture before you do your whole equation and try to solve it. But read it and see if you can make sense of it to draw a picture. So Al paints with watercolors on a sheet of paper 20 inches wide by 15 inches high. So what did everybody stop and do right there?
Draw a square.
A rectangle, yeah. 20 by 15. Does it matter the orientation? Like if it's, no, it's just our picture. It doesn't matter. It doesn't have to be perfect. So our sides are 15 and 20. If you have it rotated the other way, it doesn't matter a bit. Okay, he then places this sheet on a mat so that a uniformly wide strip of the mat shows all around the picture. What does that mean? Yeah, so basically you had your original picture and you're putting a mat behind it. So there is a bigger rectangle around this. So let's draw our bigger rectangle going around the outside. And it says a uniformly wide strip. That means the amount showing, whether it looks like it in my picture or not, is the same. So this border is the same all the way around. Did I tell you how big that border was? So what could I call that? X. But I know they're all the same. All right. So far, so good? The perimeter of the mat is 102 inches. The mat is this whole thing. We know to get perimeter, we have to add all the sides. So I need to know the sides of this big rectangle. So now we got, yeah. If it were a square, we would. But this one's a rectangle, so not quite. But let's see if we could come up with an expression for it. How far is it to get from here to here? What's that width? X. How far is it from there to there? That's the 20. And how far is it from here to here? So altogether, how long is that side? 2x plus 20. We had the 20 we started with plus the x on each side. Okay, we can do the same thing here. How far is it from here to here? X. How far is it from here down to there? And then that last little bit is x. So altogether, this side is, okay. And you know in a rectangle, your opposite sides are the same. So now we write our equation. We know perimeter, so we add them all up. So you could either write all 4 of these, or what's the shorter way? Yeah, so you can write them all out and add them all together. That is perfect. If you prefer, instead of writing the 2x plus 20, you realize there's 2 of them, so take it times 2, and 2 of the 2x plus 15s. And that equals the perimeter of 102. Now we have an equation we can solve. So if we distribute, we get 4x plus 40 plus 4x plus 30 plus 2. Like terms, 4x plus 4x is 8x. Plus 70. Subtract 70. Divide by 8. And we should get x equal 4. Now, there's a lot of different questions I could ask here. I might ask you, how long is the mat, or how wide is the mat? But the question I did ask was, how wide is the strip of mat showing? That was the X. So, say there are 4 inches showing on each side. But 12 and 15, we will add to this Monday. So it won't be collected yet, but